we got James in Phoenix. Hello, James, are you there?
I'm here. Thanks for taking my call, guys.
Yeah, thanks for calling. What do you got for us?
Yeah, I was, I don't know, actually, I don't know how you guys feel about it, but assuming you guys don't agree with, like, the distinction between, like, I think Ken Hamm calls it, like, historical science and then, like, observable, repeatable science, like, why would you guys not find that to be a meaningful distinction?
Well, why don't you give us a definition of what you mean by that?
Well, like, I guess, like, for example, like, where it comes out most often would be, like, the question of evolution. So, like, evolution, it's not something that we can observe and repeat.
Actually, we can.
Like in the lab. Okay. So maybe that's, okay, maybe what's, I'm sorry, can you explain that to me?
Okay, sure. Yeah, I mean, in the case of evolution, which is a change in gene frequency in a population over time, all right? And so you can take a colony of bacteria that grows in a specific temperature range, and you can gradually lower the temperature range so that with each successive generation, only a few bacteria will survive in the lower temperature range. And you get it progressively lower and lower and lower until you end up with a strain of bacteria that thrives in a lower temperature range than the original population. That's an example of evolution.
Okay. Yeah, I guess you're right. That would be an example of evolution on that scale. And I think Christian, or at least like myself and Christians I know, even six-day creationists like myself have no problem with adaptation like that.
That's evolution. I
guess we would.
That's
okay. If that's evolution, like as far as like evolution under that like particular like narrow definition, I'm okay with that. I mean, obviously,
that's not a narrow definition. That's not a narrow definition. That is the definition of evolution. We have changed the frequency of genes in a population with successive generations.
Okay. Well, okay. Well, then in that case, like saying that's evolution, I have no problem with that. I guess maybe what I'm talking about would be like macroevolution, because that. I mean, you guys do agree that that macroevolution has occurred, right? I mean.
Micro and macroevolution are distinctions that I guess are in some sense meaningful to people who don't understand evolution. But for people who do understand evolution, it's all evolution. So those small changes that occur in, for example, the bacteria, those can those kinds of changes in gene frequencies can occur in any species, and they can result in a speciation event.
Okay, but we've never observed like bacteria becoming something other than bacteria. I guess that's what I mean by observing evolution.
The speciation events tend to happen over long periods.
We have seen speciation though in other species like moths. The problem with the whole observable thing is that it takes way more years than a human lifespan in a lot of cases for these gradual changes to result in speciation. So that's why you can see it with bacteria, because bacteria's lifespan is really short, or fruit flies. Fruit flies don't live a long time, but humans live 72 years. So it's really hard to test more than 1 or 2 generations of a human in the lifespan of a researcher. So that's the reason it's really hard to observe some species.
But even with humans, we can observe evolutionary changes. So for example, sickle cell anemia. Sickle cell anemia is a fairly devastating disease if you inherit 2 of the sickle cell genes. If you inherit just 1, you have sickle cell trait, but usually you don't have a full manifestation of the disease. What you do end up with is resistance to infection by certain strains of malaria. And what you find is that in areas where malaria is endemic, the population of people with sickle cell trait quickly stabilizes at what is essentially the most advantageous percentage, knowing that you're going to lose a certain number of people to malaria and a certain number of people to, full-on sickle cell anemia. You're going to have a population that will survive that's in the middle that has just one gene for sickle cell. And so that's an example of evolution in action with humans.
Okay. Yeah, but I wouldn't have. I mean, obviously, don't have a problem with that. I don't personally know anybody who does. I guess what I'm talking about is the actual, because you guys would believe that we all started from a common ancestor,
Yes.
and then that divided into the myriads of different kinds of
the evidence for that
creatures that we have today, right?
Yeah, the evidence for that's overwhelming. I mean, in biology, that's a completely non-controversial topic.
Yeah, just DNA
but
alone tells you that we have a common ancestor. It's without even looking at physical traits or anything like that.
Okay, but the evidence for that though would go back into the evidence for would go back into the non-observable. Like we can observe habitation in humans and bacteria and fruit flies, but we don't observe bacteria becoming not bacteria or something other than bacteria. We don't observe fruit flies becoming something other than fruit flies. Like those are observable, repeatable things that we see, but like the actual like differentiating of different kinds of creatures or whatever in evolution, that's not observable. You say, yeah, we have the evidence, but it's not observable evidence, right?
Well, again, these things happen on a longer time scale than human lifespans.
We have seen, when we talk about, it's pretty arbitrary to say turns into something that's not that, because speciation just means it's a separate population that can't reproduce with the original population.
Or that has some kind of barrier to reproduction with the original population.
Right, enough for it to be classified as a different species. And we have seen that with salmon, for example, and we've seen it with moths. We've seen it with, some higher life forms than bacteria, but that still have relatively short lifespans. And so when we see a speciation occur, that's basically becoming a different species.
Okay, yeah, but that would still be like a world apart from I'm trying to think of an example. That would be like a world apart from like a reptile becoming a mammal, for example, right? I mean that's still a pretty big difference, right?
See, the thing is, the very fact that you're bringing this up tells me that you don't really understand what evolution actually proposes. Evolution as, and I'm talking about not evolution the fact, because it is a fact that evolution happened. And it continues to happen. But there's also evolution, the theory that is basically the model that explains all of the observable facts. I think the fact that you're asking that question about can a reptile turn into a mammal tells me that you don't understand the model, because that's not something that evolution proposes. What it says is that we have a common ancestor. So, if you go back far enough in time, you can find a common ancestor, that all living things on the planet share. And again, the evidence for that is overwhelming.
Okay, but the common, I didn't mean like necessarily that evolutionists believe that reptiles became mammals. I meant like, I guess I'm trying to get at that common ancestor wasn't a mammal, right?
Right.
I mean, I'm just trying to get at.
Well, point, it depends on how far back you go.
From something that, right, yeah.
So
but at some point we got mammals from something that wasn't a mammal, right? I mean, at some point that distinction happened.
Right.
And that would be, and I'm saying that seems to me to be a world difference than just speciation itself, where you have, like, for example, I think like we've seen speciation in cats, I think, right, where these different kind of cats can't breed with each other any longer.
Well, it's only different because you're talking about a much shorter a much shorter time between generations. So there's no point at which a non-mammal gives birth to a mammal. It's a series of little changes over millions of years that a common ancestor there'll be two branches basically. So one branch will, through a series of small changes, per generation will result in a mammal, and the other one would result in a reptile. So you never have a mammal giving birth to a reptile or vice versa.
Right. No, and I'm sorry, I didn't mean to imply that. I just meant at some point though you do have the two branches do branch apart, like they do, and I get why you would say that can't be observable because of the massive time frame that you propose would be necessary, right? So I get why that can't be observable, but I guess I'm just wondering, wouldn't it still be a meaningful distinction though to talk about the distinction between observable science and that kind of branching apart that we can observe?
Why? Because I mean, a lot of the evidence that we've compiled to support a lot of different branches of science rely on something other than, okay, I can go in a lab and do an experiment and demonstrate this. I mean, I can look at tree rings and tell you a lot about what the climate was like, 9,000 years ago. Mm-hmm. So, I mean, does it matter?
Yeah, I guess. Well, I think I guess it would matter because I encounter a lot the idea that that Christians are anti-science in the sense that the kind of science that gives us modern technology and that kind of thing. But that kind of science is the kind of science that I'm talking about. It would be the repeatable, observable science. And I think it's unfair then to lump in, questions or criticism of, that macroevolution, that branching apart with the same kind of science that gives us modern technology and that kind of thing. So, I guess that's why I would say it's the same.
So if you look at chromosomes, and say you do some chromosome tests and you have basically the chromosome map of, say, a human, and then you do the chromosome map of a chimpanzee, is that not observable science? If you look at that and you can compare those two? I mean...
Yeah, that would be observable science. I would say, though, that we... that part is observable. You can look at the chromosome map, but then we can... the question is, well, is that a matter of, do we see those similarities because we came from a common ancestor, or do we see those similarities because we have a common creator? So at that point, it would be like the interpretation of the evidence, right?
But then...
Or the interpretation of that observable fact.
Okay, but then it becomes, let's look at these two chromosome maps and find out if there's enough evidence here to test whether maybe we did have a common ancestor. What is the evidence? And that's what researchers did. They actually looked at the evidence. It's not just morphological characteristics like body type and stuff like that. Not just behavioral.
No, it's about even genes and coding proteins and even what you would call junk DNA, right?
Yeah, so there's a lot of that stuff. But then when they looked at our closest ape relatives, the chimpanzees, they found chromosome 2. Our chromosome 2 basically was a result of a combination of two chromosomes. And so it's conclusive DNA evidence. It says, or chromosomal evidence that, we shared a common ancestor.
Right. I guess it's probably something you'd say I just need to look more into or read more about. But I don't see how we would just taking that. I don't see how we would distinguish necessarily that it's a common ancestor instead of a common creator, common design.
Well, and given the fact that no one's ever presented any credible evidence for a creator in the first place, I mean, on what basis would you say God did it and close the book and say, okay, we don't need to ask this question anymore?
Sure. No, I think asking the question is a great thing. I mean, I think doing these things is a great thing.
But see, the thing is,
so I'm not advocating closing the book.
But that's one of the reasons that a lot of people say that Christians who deny evolution are anti-science. Because basically, if you point to it and say, well, it's because God did it, that doesn't ask any more questions. It doesn't provide any more answers. That basically shuts down inquiry right there.
Well, I don't see how looking at it and saying, okay, we have this evidence, this evidence that we're observing, and at that point, then it becomes like, after we have the evidence that we're observing, it becomes like an interpretation of the evidence, it seems like. So I don't see at that point, like, why one, like, at that point, if both common creation and common ancestor both explain it.
Well, I don't think common creation isn't really an explanation. It's, common descent is a mechanism that explains what we see.
Yeah.
To say common creation, well, there's no evidence for a creator in the first place. So you have that to deal with. But you can look at how chromosomes change over time and mutate even in 1 or 2 generations and project that. Okay, how are these going to add up? And you can model that, and you can see, here's how chromosomes and DNA, here's the rate that mutations would happen, and this is kind of what you'd expect, and you can make a prediction from that, and then see if what we see matches that prediction. But to say common creator, you can't really make a prediction or answer any questions about that. You just say, okay, well, I'm going to assume that this is how it happened, and then you're done. But it doesn't really help you investigate anything.
So, by saying the common, like if you say, all right, I look at this evidence and I see common creation, would we not expect the same certain genes and the same certain, even junk DNA, which we're finding a lot of times, we find that this junk DNA actually does have a purpose and actually does do things. It's not necessarily just pointless stuff. Could we not say, hey, if there's a common creator, could we not predict or expect that we would find the same genes and the same proteins and all whatever and amongst different animals, different creatures?
Well, but the thing is, on what basis do you conclude that there is a creator?
Right. Oh, okay. So you're saying what basis do you even initially
basically
conclude that there is?
You've got a story that the DNA is telling you, and now you're instead of continuing to ask questions and investigate how it got here and accept where the science is leading you, you're just shoving a God in there and saying, "Oh, God did it."
Okay, so I think I hear you. So you're saying why you believe in a creator in the first place? Why are you even believing in a creator in the first place? Well, that's what you're saying as far as that goes.
Why would you insert a God in the equation when it isn't necessary?
Right. Well, I would say he is necessary, but the reason I'm a Christian, the reason I believe in God and a creator is because the reason I'm a Christian is because God has changed my heart by the Holy Spirit. He has brought me into...
you believe in Christianity based on a personal experience. Okay.
I guess you could say, yeah. I would hesitate to say based on a personal experience. I just know, God has he's revealed himself, right? And he's revealed certain things. And one of those things is that if you are a Christian, if you are a believer, it is because of his work. Now, I think that there are evidences that things that confirm that for me, and that confirm my belief for me. But I know that it started with God and God changing my heart.
I think what we're getting at is that you believe in a God for a different reason, and once you believe in God, then you're looking at the diversity of species, and you're saying, hey, I can take this God I believe in and use that to explain this. So it's kind of a backwards approach. You already believe in something, and then you're making that the explanation, rather than looking at what the result is and the evidence and working back to an explanation.
Well,
so that's why we say it's not scientific, because you're kind of presupposing the cause and then kind of justifying what you see based on that cause you already believe in.
Well, and I would also point out that Francis Collins is one of the preeminent, scientists, evolutionary scientists on the planet. Okay, he's also a strong Christian, and he does not believe that God did it. You know, he believes that evolution is the answer. It is a fact, and that the theory of evolution explains the diversity of life on the planet. Now, he is what you call a theistic evolutionist, which he believes in theistic evolution, which basically evolution is the mechanism that his God uses to create this diversity. But he doesn't question evolution or its mechanisms.
Okay. Yeah, I know theistic evolutionists. Yeah. So I would go. I guess go. I would want to go also about the point of presupposing a God. I mean, I don't believe anybody's neutral. You know what I mean? Like, you know, I don't believe that just because someone doesn't believe in God, that all of a sudden that makes them neutral when they come to this evidence, right? They're also interpreting the evidence themselves through some sort of framework, right? So
yeah, the scientific method is the framework. It's the only legitimate framework to use when interpreting the evidence.
Right, the scientific method, but how, then I guess that goes back to what we were talking about, like when we're talking about like the branching off, like how are we applying the observable, repeatable scientific method to that, you know, that seems like more like, hey, we see evidence that we think indicates this, but it's not something that we can observe and repeat in the laboratory like we can.
That's not the only way to do science. You guys have it in your head that the only way to do science is to create an experiment in the lab and do it and then repeat it and publish it.
See it happen, yeah.
You know, see it happen firsthand. That's not the only way to do science. There are entire fields of science that are not based on sitting in a lab and doing experiments. In fact, there's a bunch of guys down at the South Pole right now that are doing science that doesn't involve sitting in a lab.
That doesn't, yeah, okay, but are they, okay, what kind of science are they doing?
They're drilling ice cores, and they're looking at what the climate on the planet was like and what kind of, in some cases, they end up with samples of bacteria, or they find other, you know, organisms that were trapped in the ice and preserved for, you know, long periods of time.
Right. I'm sorry, go ahead.
Oh, I was just going to add, archaeologists, you know, they're not observing the ancient cultures. They're seeing what evidence is left, and they're using that to make, you know, educated guesses about what this culture was like based on what they find in their archaeology. So you don't necessarily have to directly observe to take some evidence and, you know, and make some determinations about what happened.
Right, but that kind of science though is primarily interpretive, right? Like they're interpreting what they're seeing, or what the ice cores they're uncoring, or the you know, artifacts that they're digging up. They're interpreting these things, right? And they're collecting
evidence. They're collecting evidence, and they're applying the scientific method to evaluating that evidence to determine how it fits in with whatever the current framework is. And sometimes people come up with evidence of something that overturns previously held views on a topic. And when that happens, people get famous. So I got to tell you, if you ever come up with a scientist who can demonstrate conclusively that evolution is not what happened, if that's not how we got the diversity of life on the planet, that it's not real, if anybody can overturn evolution, that person is going to be famous. They're going to be so wealthy beyond belief. So please encourage them to publish their evidence that evolution isn't true. And especially if they can prove that a God did it.
Yeah, well, I would say that, going back to the myth of neutrality here, like...
why do you keep doing that? Why do you keep coming up with this neutrality thing?
Well, I guess I just mean in the sense that like God did it and that kind of thing. Like, I guess I'm just pointing out that one side is not neutral because they're saying, because they don't believe in God, and the other side's not neutral, or, you know, I'm not saying this right.
You're the only person in this conversation that thinks that's important. Because John and I think it's important that people rigorously follow the scientific method in determining whether something is true or likely true.
Yeah, I don't see a bias in science that says God didn't do it.
Yeah.
I see science as looking at the evidence and coming up with the best explanation. And I guess the bottom line is that there's no evidence that God did it, so science doesn't go there until there is such evidence. But science isn't saying, well, I'm going to come up with any explanation I can as long as God isn't it. That's what I would call a non-neutral position.
Okay, so I guess maybe to go to something that where there's no question about what we know, for example, the cell, I'm not saying we don't know how the cell operates or what's going on inside the cell, or all those marvelous things that are happening, right? So I guess maybe I'm just trying to clarify my neutrality thing. So I'm not trying to claim I got in the gaps. We know what's going on. We know how the cell operates, right? I would say that evidence though is going to either be interpreted as we see this amazing, what can only, to me, I would say only can be called design. I mean, look at how the cell is functioning. That has design written all over it. That's an interpretation.
No, it doesn't.
To the person.
How do you get design out of that? I mean, it.
I would say because anything else that we encountered that had that sort of functioning and complexity, how would we not? We would automatically go to design, right? I mean, to me that's an obvious thing, right? If we were to
No, if it were obvious, then scientists would go there. But the fact is, it's obvious that the cell was not designed. And scientists have concluded that that's the case because they have rigorously applied the scientific method. And there's absolutely no evidence that it was designed by something else. So again, if you have evidence that a designer exists and it did these things, by all means, present that evidence. You'll be famous. And probably very rich.
So that's I guess where I was coming at with obviously I believe that the reason that you don't see design there is because you are not in a neutral position toward God. Now,
and you think wait,
you deny that. I'm just
the non-neutral position would be this default that you have that there has to be a designer. And to me, that's just a failure of imagination. I mean, there's absolutely no reason to posit a designer for a cell. No evidence points to that.
If we encountered in any other sense, if we encountered something that was
again
self-replicating and could,
what you're doing is that you're again demonstrating a failure of imagination. What you're doing is not an argument in favor of a designer.
It's really an argument from ignorance. Which doesn't mean you're ignorant. It means that it's
I understand.
The argument from ignorance is I can't think of another way this could have happened. Therefore, God is the explanation, or generically, I can't think of a way this happened, therefore it must be cause X. Just because you can't think of a way that something could have the appearance of design doesn't necessarily mean that it was designed.
Yeah, and I would say, this is just, I don't think this is going to be a disagreement we're going to resolve. I'm just, the disagreement there for me is that I think that, I believe that is designed because God has revealed himself in that, and you believe that, and you guys looking at and not seeing design, because God has not yet, changed your hearts, open your mind. And I know that's two different things that we're not going to see eye to eye on.
Especially when you put it that way, because this whole, God has not yet revealed himself to you. I mean, that's a really arrogant thing to say. I'm a former Christian. I'm not a Christian anymore because I realize that my former beliefs are not supported by reason and evidence. So, I mean, this idea
I'm
that
not yet. I'm sorry. Go ahead.
no, I mean, this idea that, you know, there's this being out there that wants some relationship with me, but he's playing hide and seek, and that if only I will believe, then he will come into my life and, you know, whatever. That's an incredibly arrogant assertion.
When I said not yet, I just meant I'm not leaving out the possibility that he may one day do that. I would say that the
He doesn't exist.
Is,
Jesus is not coming back. He doesn't exist.
Yeah, I know you believe that, and like you know, I realize that you know I'm not going to come up with some like amazing argument right here and now that's going to convince you of that. You know.
Yeah.
Right, but you could come up with an amazing argument But you could come up with an argument that says, okay, well, here's why a cell had to be designed, and you could, if you could do it scientifically, you could convince people that there has to be a designer, that there's no other possible explanation that a cell could have, you know, and if you did that, you may at least be able to prove a designer.
Yeah.
Now, whether it's a particular, you know, God named Yahweh who's, you know, that would be another thing, but you could at least, if you had the evidence, prove that there was a designer. But right now, it's more of an assumption based on a God you already believe in, that, you know, here's this thing and it looks like design, and I believe in a God, so therefore God's the designer. That's the kind of thing that you know, scientifically isn't going to fly as an explanation.
Oh, I mean, it's confirmation bias, basically.
Yeah.
You already believe, so you see evidence that confirms your belief.
Okay, as well. I feel like at this point we'd probably just be going in circles, but I do appreciate you taking my call.
All right,
Okay.
thank
well,
you.
Appreciate your call.